Hello, my name is Rich Howard, owner of Architectural Builder Supply, and this video is to bring you a closer look at the Hess 5000-501 electric strike. This is a grade 1 electric strike, very common and typical that I think you're going to be able to use in lots of different applications. You know, grade 2 cylindrical lock applications, grade 1 cylindrical lock applications. Anywhere where you have a latch bolt whose projection is between 1/2 of an inch and 5/8. Anything larger than that won't work in this strike, meaning a 3/4 inch projection latch bolt like you'd have on a mortise lock or an exit device, or a Pullman latch, different type of latch. And this video is going to review all aspects of this strike. So let's first go over the extended description information, giving a summary. First of all, this is the 5000 series strike that is going to have the 501 faceplate, which is, if you have a hollow metal frame, this is going to work out splendidly for you. So there's the business end of that strike. And when you add the 501 faceplate to it, it's going to look like that. Not a lot of prepping that you need to do to the frame outside of the rest of the rabbet of the frame. Not even much, a little bit, but more so the face of the jamb will need to be prepped a little bit. This is a grade 1 strike. That means it's been tested to 1,000,000 cycles, which is really phenomenal for the price range of a strike like this. Something that's rated for that many cycles in that price range. You could easily spend 3 times the amount. Stainless steel construction. That's going to have stainless steel components on the inside of it. Tamper resistant. Has a static strength of 1,500 pounds and a dynamic strength of 70 foot-pounds. They say that the endurance rating is 500,000 cycles. I understand grade 1 is 1,000,000. There might be a different definition for grade 1 when it applies to strikes. I understand it to be 1,000,000. Field selectable, fail safe and fail secure. That means in the absence of power, is the strike locked or is it unlocked? And you can change that mechanically on the strike, and we'll go over that. The applications of those, when you would want one over the other, we'll discuss later as well. You can run this in either 24 volt, 12 or 24 volt, AC or DC. This does not come ready to go AC out of the box. Yeah, you'll need a rectifier if you're going to run this on AC. We'll talk about that in a moment. Non-handed, completely reversible. You can put it on left-hand or right-hand doors. Internally mounted solenoid, meaning it's encased within the unit itself. There's nothing exposed. Okay, all integrated into one sealed box. Accommodates that 1/2 inch or 5/8 latch bolt with a standard 1/8 of an inch door gap. You want to measure the projection of the latch bolt sticking out of the edge of the door. It should be 1/2 inch, certainly if it's a grade 2 lock. But if it's 3/4 inch, this strike will not work, and you'll need maybe a 1006 from HES for doing that. Strike body depth is 1 1/16, and we're going to get to the dimensional properties next. Features plug-in connectors, and a trim enhancer is also included, so that should you need to cover up maybe a little bit of additional preparations that have been done in the frame, you can also add this trim plate. So if it's a new installation, you wouldn't need it. But if you're replacing one, you might need that trim plate as well. The 501 faceplate is a 4 7/8 tall faceplate that's intended for use on a steel frame. 4 7/8 by 1 1/4. Does not require removal of the dust box, and that's what's really nice about this strike. A typical hollow metal frame, you would normally have to get in there with a chisel and break the spot weld on the dust box, and that's not a pleasant operation to go through, because breaking the spot weld is usually akin to tearing the welds apart. So you've got to get in there and bust that out. That's not what you want to do, especially if that frame's been pumped with mortar. you'd want something that's going to fit inside of the dust box. So for an existing installation masonry application, which is very commonly where you'll install this, you're absolutely going to want an HES 5000 with a 501, a 5000 strike, so you're not breaking out that dust box. Next, let's move to the dimensional properties. Now, let's take a dimensional tour of this strike, which we've very much already started, but let's complete the dimensional tour of it. Overall height of the body, about 3 3/8. Overall depth, about 15/16. It's going to have an overall width of about 1 3/4 or so. Again, that strike plate we've already measured at 4 7/8, 1 1/4. Okay. Now let's take a tour of the parts that you're going to get in the item itself. So you're going to get, of course, the strike body itself, and there is a link below this video to the installation instructions. You're going to get the body. You're going to get that trim enhancer as well, and the trim enhancer includes 2 very small screws that you will need as well to hold that on, should it become necessary. Let's show how that's going to go again. Something right like that. I don't have it centered over the holes real well, but right in that range is what that's going to look like. Let's take those dimensional properties of the trim enhancer, also known as a scar plate. That overall height's 4 1/4 with an overall width of about 1 1/16. Getting this installed, I mean, is obviously, you know, what dimensions it's going to give you when it's installed. And we're going to go over the frame preparation next. You know, that overall height's going to be 4 1/4. That'll bring you back its width as well, about 1 1/16. Trim enhancer and its 2 little screws. You're going to get the pigtails and the wire nuts that you're going to need, and these are what is going to regulate whether you're doing it 12 or 24 volt. Okay, based on what's happening inside of there. I imagine there's a you know, there are electronics happening on the inside of those to make sure that you're feeding it the proper voltage. Then, of course, your 501. Your 501 is going to give you the faceplate. It's going to give you the 2 screws needed to hold the faceplate onto the body. What are we doing here? To hold the faceplate onto the body, here and here, and then the screws, there are 3 of them in this package, you only need 2 to hold the strike onto the steel frame. That'd be a 1224 flat undercut head screw that's there. Now, moving on to the frame preparation, and there is a link below this video to the installation instructions that will allow us to go over the frame prep, and only because we're dealing with the dimensional properties. I see it there on page 3, and a very small amount of prep. These installation instructions include dimensional properties for different faceplates that you know, don't need to be concerned with because you're not doing this preparation. You're doing a 501, I mean to say. And that's one thing you really notice about installation instructions like this and door closers and other pieces of hardware. There's all this paper. There's just so much of it. And then you realize what applies to you is usually not more than 3 pages. And one of those pages is a parts breakdown. The other is the business end of what you got to do, and then the rest is what you need to know to make it fit. So, you know, there's your 501 faceplate. So the prep, if you're doing a hollow metal frame, the preparation you're going to do, it's going to be over here. You're going to make sure that you've got an 11/16 of an inch cut back on the face of the frame itself, and that it's going to be 3 3/8 of an inch high. So your frame preparation is going to be basically closed off here, and you're just going to open up this area that's at the tip of my finger. Just 11/16. If you have a common hollow metal frame, it's a 2-inch face. You got to come back 11/16, then up 3 3/8. You can mark that off. You can jigsaw cut it, die grind cut it, however you're going to end up doing it, to just open up the requirement to basically fit this section here. And when we had said earlier about that dimension being about 11/16, that's where the 11/16 comes in. You would use that trim beautifier, or whatever they call it, trim enhancer, if your cut's poor, wavy, sloppy, you've cut on an angle, you want to dress that off. You get good enough at it, and you're going to make a really straight cut. Absolutely wear eye protection, ear protection, and gloves, because when you're cutting up with a jigsaw, that material's coming right in your direction. Okay, now, the frame preparation at that point, as they had said earlier, does not require removal of the dust box. And if it's a steel frame, you've already got the 4 7/8, 1 1/4 prep to fit the 501 right into it without any trouble at all. Obviously, pulling power is going to be something that you'll have to contend with. How you'll do that, that's not going to be included in this video. And what we're going to do next is start with literally the installation instructions, right where it's start to get it installed. Now, let's start with the installation aspect of this material. However, first, it's important to take note of what are the electrical characteristics of what you're about to power up. So, this is a DC strike. It has a DC solenoid in it, and it's on the bottom of page 1 of the installation instructions. If you're running it at 25 volts DC, it's got 50 ohms resistance, and is pulling requires a 0.24 amp. 24 volt, you're going to have 200 ohms of resistance, and requires 0.12 amp. So that's important to know when feeding this item with power and power supply, making sure that you've got the proper voltage to it, making sure that the proper and adequate amount of amperage is provided as well. Now, if you're running it with alternating current, which is no problem, you're just going to need to AC power coming in to your rectifier, which HES sells rectifiers as well. Listed down below this video, you'll see if you're just using a transformer versus a power supply, and you're going from line voltage and just stepping it down to 12 or 24 or 16 for that matter, but in this case 12 or 24, you'll need a rectifier. The electrical characteristics of running this, first of all, on AC voltage, is that the solenoid is intended for intermittent use only, which would mean that you would probably be running a fail-secure installation, meaning without power, it's locked. When you energize it, you can unlock the door, and you're in good shape. Running it on AC will give you that buzzing sound naturally. But of course, being a DC strike, if you need an audible indication of what's being done, you'd add the buzzer that's available, which plugs in. It's an annunciator that will give you that effect. 12 to 16 volts AC, it's going to draw 0.24 to 0.32 amps at 50 ohms. 24 volt AC, 0.12 amps, 200 ohms. Back to the intermittent duty, fail secure, energize it to lock people the circuit is opened and then power is cut and the strike is relocked automatically. Because the solenoid, when running on AC power, is intermittent, has a 10% maximum duty cycle, meaning don't run it for more than meaning it's intermittent use only. Don't run it for more than 2 minutes at a time. And this strike is indeed intended for interior use only. There is a minimum gauge requirement table that's down here below, and you're going to absolutely want to be aware of this. The gauge of the wire based on the voltage and the distance from the power source. That is incredibly important because you can indeed expect it not to work if you have inadequate wire gauge coming to the material. I was called to a job on a HES strike as well. I was called to a job site, and third shift was starting on a Saturday. The door wouldn't unlock with the credentials. It had worked for a while, and then there was some construction that happened inside, and all of a sudden it didn't work anymore. Drive the 45 minutes to get to the job site, and indeed it worked intermittently. And the strike that it was working on had a couple of articulating arms that controlled the keeper. One's on the top and the one's on the bottom. When it would fire, what was interesting, when I disassembled it and tested it, the bottom keeper would open, but the top wouldn't always open. It would sometimes, but not all the time. But the bottom would always unlatch. So they could either get in or not, but that bottom keeper was always falling open when it was energized. Long story short, realized that the construction they did moved the power supply 500 feet away. That the amount of resistance that the current encountered the entire distance dropped it below the amount of amperage necessary for it to operate consistently, causing the problem. Discovering the problem really drove home the importance of adhering to gauge and minimum and maximum distance between power supply, transformer, and the strike. So adhere to that, please, or it's just not going to work. Okay, now we're going to move on to the actual assembly of the item onto the frame and getting it wired up now that we understand the electrical characteristics. Now, moving on to step 2 of the installation instructions, what we're talking about is preparing the strike. It states, select the appropriate plug-in connector based on the voltage that you're going to be powering to the unit. What they don't mark on these pigtails is for 12 volt AC-DC or 16 volt AC, use the 12 volt DC pigtail. And if 24 volt AC is used, use the one marked 24 volt DC. Now, step 2 in the installation instructions, verify that the strike is in the correct mode of operation. The unit ships fail secure. If you need to convert to fail safe, see diagram 4. Okay, so let's talk about that. All right, they don't give us any information regarding any markings on the back. But here's what we know. There's no power to the strike. We know that. And we know that the keeper is locked. Okay, that's what for sure what we know. Fail secure is what that is. If the power is, in the event of a power loss, then remember this anyway that that strikes a chord with you. I think of it as when the power's out, the normal state, your door is secure. Fail secure. Fail safe, you can think of it as in the event of a power outage, it would be safe to exit. That doesn't really make sense, but it might be safe to move through an opening when the strike is de-energized, meaning the keeper is always open. And it's only when you're supplying constant power to it that you would have a locked condition. A similar concept might be not necessarily going to help you remember it, but you have a door closer that is has an electrified component to it that is wired to the fire alarm panel and has the ability of keeping the door open at 90 degrees, powered open to 90 degrees. Cross corridor. You've got, let's say, 2 of them, double egress. The doors are always opened. Therefore, they're always energized. In the event of it receiving a signal from the fire alarm panel to open the circuit, cutting the power, those doors will now close, is what they'll do. That might be a way to remember it as well. I just think of it as fail secure. In the event of a power loss, the door is secured. Fail safe has to be the opposite, so that might work as well. Let's manipulate the condition of the strike now. So we're going to notice, again, we're going to confirm that this is in a fail secure situation. And basically what it says in figure 4, loosen the 2 very small screws, 256 screws located on the back of the strike as shown above, but do not remove them, just loosen them. Move the screws from the top of the hole in the fail secure position to the bottom hole, fail safe position. And tighten, and then verify. Verify the strike is now in the fail-safe operation mode. If the strike still operates as fail-secure, be sure the screws are fully seated in the bottom position. So right now, that's fail-secure. I mean, depending on the hand, doesn't really matter. It's secure. I can't move the keeper. Loosen but don't remove. How many turns does this take? Okay, I have an ill-fitting screwdriver. Okay, we're going to get the right screwdriver. I should have recorded, because I paused the video, on what it took to loosen those screws. You have to have a perfectly fitted screwdriver, and I don't own lots of really great tools, but this company right here makes some really nice screwdrivers. A proper fitting screwdriver. I was able to loosen those screws using a substantial amount of force to get it to move. And I only turned it maybe 2 revolutions, and that little screw did indeed come out. The problem is, and I can see that there's thread lock in there, and I can understand why. You don't want to lose them because they're a number 2 screw that has a 56 thread type. I'm going to remove them all together because I'm not concerned about losing them. I'm trying to determine how we're going to manipulate this to move it. It is unclear how we're going to have to solve this mystery. Well, I was able to get that coaxed properly, but I can tell you that I feel as if I've saved you all the trouble of having to determine what exactly the problem is. And like with all things hardware related, you literally need to follow the instructions. Literally follow the instructions. You had noted earlier, if you did, I had actually removed the screws, not feeling that that was going to be a problem, so that I could slide the mechanism, understanding what had to happen. Well, I did remove them, but in no sense could I get anything to slide. But the installation instructions specifically state, do not remove them. So, based on my experience, I went back to where it was and did not remove them, and simply had them threaded in to the point where they were still captured, but were loose. At that point, what I did was, I simply took a flat ended instrument and coaxed it and moved them both in the opposite direction. And that moves something internally. Locked. When I coax them back, just using this small screwdriver, then tighten them again. By doing it equally, I can get it to creep up and move again. I have to admit, I'm not in love with this method because I've obviously done this with other strikes and have never before done it with the 5000 series. So I have to admit I'm not in love with that system, but it does work, and I've done it now multiple times. I've got it set back to fail secure and tightening the screws just by hand. We don't want to over tighten anything. And that's the procedure about how to do that. Sorry you had to sit through that. Okay, now that we've properly demonstrated fail safe and fail secure settings, we are going to go through the balance of the installation instructions, which will not be very much. Now at this point we're going to look at the balance of the installation instructions from the factory, and as we had said much earlier, you usually get a summary page of what you're getting. Then you're going to get all the information necessary on a page. Then you've got another page showing different faceplates, and really all they're giving are the different dimensional requirements of what you're prepping. That's the fail-safe, fail-secure in your 501, but then the rest of it is just other faceplate modifications. So frame preparations, modifications for HES strikes. Now I remember when HES strikes came out, I just remember saying to myself how brilliant it was that they had these interchangeable faceplates. And that continues today to be as important as it really ever was. So they do a really great job when it comes to that. Now the balance of the extended description information in the website shows you other options. We almost completely talked about them, but transformer you can purchase, the rectifier, the annunciator, you know, the audible buzzer, an LED indicator should you need that as well. You want to see something coming in. Certainly if it's DC, where there is no sound other than really a click. And then press fit stackable extensions, lip extensions, which are important if you need to be able to build off the face. Here's your strike. Well, what if you have a deep inset where the door is pushed into the frame deeper, or you've got unusual casing, so you can add extensions to extend this dimension here, should you need to. And that absolutely concludes everything that's in the package. I'll summarize this video by saying there's a link below this video to the manufacturer's page where you can pull up not only all of the HES products that we sell, but a link to the manufacturer's website, as well as a link to the full product catalog. Now, the name HES is part and parcel and a part of the Assa Abloy Group companies, which is it's a multinational, multi-billion-dollar, I'm sure, corporation that encompasses lots of different industry. But in the door world, they're going to be able to supply you with everything as it pertains to a door. The doors, the frames, the hinges, the locks, the closers, the electric strikes. The technical support at HES is, and I don't call them often, and it's kind of because you don't have to call them often, although I was about to with that fail safe, fail secure. But the times I have called them, the responsiveness has been exceptional. And that is shared with other sister companies of HES, such as Adams Wright, for instance. Great customer service, great technical support, great quality product in a part of the market that I think you'll be able to expect great performance and stand behind the product as you supplying it to your client, as we can stand behind it, as they can stand behind it, so it works great for everybody. If you have any questions on the HES 5000 series strike or any other HES product, please feel free to reach out to us. Thank you.